and turns at a velocity of 8 pi radians per second. Okay. So, in general, let's first take a look at just a general equation for this. I'm going to use, you can use sine or cosine, doesn't matter, because it depends on where your piston is starting in the cycle. So if it starts at its maximum distance away, then you'd use a cosine curve. We'll assume that we'll do that. If it starts halfway between a maximum, we'd use a sine. But in a second, you're going to see it's not going to matter, because we're going to measure a distance from the starting point to 3.45 seconds, and that's going to be the same regardless of which function you would use. So if I told you to use the cosine function, can you tell me what it would be given this information? I'll start you out. D of t equals 8. Very good. 8. Because A is the radius of the wheel, and you're told it's 8. Cosine yes. W is the rotation, W radians per second, and I said it was 8 pi radians per second, so 8 pi is W, okay, and then a T. So what is the frequency then of the piston? So I'm going to use my frequency formula, and I'm going to do W, which is 8 pi, divided by 2 pi. We will in a second, yes. But we can do 8 pi divided by 2 pi. What is the frequency? 4. Okay. So what is the period then? It's the frequency 1/4. Okay, and that's helpful when we're looking at a graph, because if the period is only 1/4 of a second, basically, we are not going to want to make a super huge window to see this, right? So if I wanted to find the distance from the starting point to 3.45 seconds, we're going to graph it in a second, couldn't I just figure out what its distance was at 0 and its distance was at 3.45 and subtract them? Does that make sense? Okay. So, and also, if it's negative, we are going to make it positive. I'm just going to take the absolute value of those things. So I'm going to write this. The absolute value of D of 3.45 minus D of 0. I don't know if it's negative or not because I haven't looked, but all right. So yes, let's switch our calculators back to radian mode. We can do D of 0 in our heads, okay? If I plugged in 0 here, isn't this the cosine of 0? Okay, think unit circle, people. What's the cosine at 0? 1 times 8. So D of 0 is 8, okay? Let's do 3.45. So I'm just going to plug in 8 pi times 3.45. Okay. So or an easier way to do this would just be subtract 8 minus 2 point. Okay. So I get then the distance from, because the position at 0 was 8 and the position at 3.457 was this, the difference between those two is how far the piston traveled in those first 3.45 seconds. So I would write down 5.528, and this is in centimeters. Okay. How we doing? Okay. Any questions so far? No? You're just quiet? Would you guys look at page 431 in your book? At example 6, there's a picture of a spring on there. Okay. So 431. Yeah, 431. So hopefully you can see, so here's like the weight attached to the spring. Do you see initially it starts at 0? Okay, and then, so if I was taking this from the picture, do you see how it starts halfway between its maximum and minimum? Okay, so I'm going to pick a sine curve in a second, because a sine is the value at 0 is halfway in between its max and min. So it's starting times 0. Then do you see how it stretches? Okay, to -5 and then back up to 5 above. Does that make sense? And if it was doing the same thing over time, okay, it's going to be cyclical, meaning it's going to attain those same values depending on the frequency or period. So what I tell you is this. The weight is displaced a maximum of 5. So if I'm telling you the maximum of 5, I know this is not circular, okay, so it's not the radius of the circle, but what is 5? Where does it go in the equation? For what letter? For A. Good. And then I tell you one other piece of information, because really on these problems I have to figure out what A and W are. And the piece of information I tell you is it takes 2 seconds to complete one cycle. What if I just told you, if I tell you it takes 2 seconds to complete one cycle? Yeah, what's the name for that though? Good. The period is how long a sine or cosine takes to complete one cycle. So really what I've told you then is the period. Well, above, what was our equation for the period? 2 pi over w. So what I'm going to do is I'm going to use that equation and I'm going to set it equal to the actual period, which is 2, and this is going to allow me to figure out what w is. So yeah, if I multiply through by w and then divided by 2, right? Or you can just look and see. Pi is what w is. Okay, and again, at this point, it wouldn't be wrong for you to pick a cosine equation depending on at what point the cycle of the spring is starting, but let's assume that it starts in the middle, halfway between a max and a min. In other words, it starts at 0, so I'm going to pick the sine. So I'm going to write d of t equals A, which we said was going to be our max, 5 sine of w times t, which would be pi times t. Okay, now let's just say because I'm going to assume that you can plug things in your calculator, okay? Let's just say I said, hey, what is its position after a half of a second? Well, what I would just do is I'd plug in 0.5 for t. Let's see, I'd say 5 sine of 0.5 pi. And then what this equation gives you is, okay, it actually reaches a maximum there, 5 centimeters. That's its position at 0.5 seconds. If I said, hey, how about at 0.1 second? What's the position of the spring at 0.1 second? Then I just take 5 then it would be 1.54 centimeters. And if you're visualizing, again, where that spring is, okay, so it's up a little bit from its initial starting position. Let's take a look at the graph. So if, let's say I ask you to answer some other questions that involve graphing. We're in radian mode, which is good. What you want to take a look at then is the period. And we said what was the period earlier on. Yeah. So if I want to graph then a couple periods of it, like let's say I wanted to graph 2 periods, I would only graph like 0 to 4 seconds. Also, we know the min and max are 5, so we could make our y min and y max a little above and below that. And then that is the curve that models what the spring is doing. So really today when you're doing these harmonic motion things and you're wanting to graph, make sure you find the period first, because sometimes they're really, really, really small. If it's a period of 1/4, like we said this one up here was 1/4 of a second. I'm going to just quick show you what happens if you make your window too big. What was this one? 8 pi. Oh, what did I do? So why does it look like that? Because I graphed 2 seconds, and its period's only 1/4 of a second. If I wanted to graph 2 periods of this, what would I make my x max? Yeah. Watch how I get a much better picture if I do that. Also, what would I change here? Yeah, we know it's going to 8 and -8, so I'd want to maybe change this up and down. There we go. That's a lot nicer picture than of the top one. Okay, and so make sure you look at some of those things when you're graphing them and adjust your window to make it appropriate so you can see what you need to answer the question. Alrighty, so